3, we're going to talk about water supply. And truly, this is one of the main functions of the engine company: supply water from the fire hydrant or from a water source to the attack engine or to the fire itself. So we refer to hydrant hit, or these are a few of the things we're going to talk about. The hydrant hit, or the making the attachment to the hydrant and then working off that attachment. The brake operations, or that seat on the engine. So remember, we have the hydrant seat and then we have the brake seat, or the brake firefighter. We'll also talk about rural water movement operations. That would be operations whenever we don't actually have a hydrant to work off of. With this operation, rural water movement, we'll be working with streams, ponds, or other options as far as moving water to the scene. This may also involve using tank operations or tank trucks. So we think about one of the goals of the engine company, again, is hitting the hydrant, making that connection. We need to think about the importance of moving water from the hydrant, or moving the water from the water source to the fire scene. For the apparatus and the Alpha Fire Company, they have a minimum of 750 gallon water tank. So with that 750 gallons of water, flowing a hand line at 150 gallons a minute, that means that we have roughly 5 to 6 minutes of water supply on the engine before that water supply is going to run out. Now that's at the efficiency of 150 gallons a minute. But we need to think about, with that 5 to 6 minutes, we need to potentially have another water source, or we need to back up that water source off the engine. Because ultimately they refer to as the tank on the apparatus as your booster tank. Only enough water there to get you going, but we still need to create a continuous water supply. The hydrant position, as you move through the engine Pert program, would be the first position you're going to qualify for. We arrive on the scene. The first thing we need to do is establish a water supply. So the first person coming off the apparatus is going to be the hydrant person, making that connection to the hydrant. And again, that's why that's going to be the first position you're going to qualify for. This is an independent operation. We need to train you to that level that you can efficiently connect to the hydrant, or make that connection, and a quality connection to the hydrant before the apparatus moves forward. Or also think that once you pull the hose line off the apparatus, you wrap the hydrant, you signal for the driver operator to leave, you're going to be stuck by yourself. You're not already stuck by yourself, but you'll be at the hydrant by yourself making that connection. So that's why I refer to this as an independent operation. We're going to review 7 main parts of a fire hydrant. So you'll see here on the screen, it talks about a dry barrel fire hydrant. The 2 different types of hydrants you're going to find in the fire service or in the water supply are going to be both a dry barrel fire hydrant and a wet barrel fire hydrant. For our climate, or for our area in the United States, with the frost line, or that we have freezing winters around here, we use a dry barrel fire hydrant, so the water is going to stay. So if you look on this picture here, the number 6, or the base of that hydrant, is where the water is going to be located at majority of the time. And then whenever we need to use the hydrant or get water out of it, then we're going to use the hydrant. We're going to open the valve closer to or down at number 6, the base of the hydrant. The water is going to flow up through the hydrant, and it's going to supply us water at ground level. For some areas that have a much warmer climate, you're going to find they'll use a wet barrel hydrant, which means the water is wet, or water is at the top of the hydrant all the time. If you ever watch the movies in Hollywood, or the vehicle runs into the fire hydrant, you see a streaming geyser of water, that's a wet barrel hydrant. For our area, if somebody hits a hydrant and knocks the top off, there's no water comes out of the ground because the water is not at that level. The water is still contained at the base. So starting with number 1, number 1 is going to be the stem nut. This is really the operating stem that goes vertical down through the center of the hydrant. The stem nut is also where you're going to place your hydrant wrench. Number 2 is the bonnet, which will be a top cover to the fire hydrant. We're going to talk a little bit about different colors of bonnets. Just understand that the bonnet is really just, a cap covering the mechanism, as far as you'll see a little bit of a screw valve right there at the top. The steamer outlet is going to be the larger outlet on the front of a fire hydrant, so that's labeled number 3. Generally, they're going to be a 4-inch or 4.5-inch threaded connection. It's going to have male threads on it. Number 4 is the residential outlet. You'll find the residential outlets will be the smaller ones on the sides of the hydrant. Generally, they're going to be a 2.5-inch connection, also male threads. Number 5 is the barrel of the fire hydrant. Number 6 is the main valve, and number 7 are the drains. You'll see at number 6, so looking at this picture, would you say that this hydrant is open or closed? All right, so the answer to that is the hydrant is open, because you can see that the main valve is pushed down into the boot where the water will be at, and that will allow the water to flow up through. If the hydrant is in the closed position, you would see no opening in the area of the number 6. The number 7 is indicating the drains. So it's very important that whenever we use a hydrant, we make sure the hydrant's going to drain. So once you close the hydrant, you look inside of it. You should be able to see the water starting to drain down through the hydrant. Also, if you put your hand over the top of the residential connection point, you should be able to feel a vacuum. We want to make sure that the hydrants are going to drain. If they do not drain, then we're going to notify the water company and have them service the hydrant. Generally, even if the hydrant does drain, we contact the water company following the incident and let them know that we used the fire hydrant and that they need to go out and service it and just verify that everything is working. The issue if a drain does not work, you operate the hydrant, you fill the barrel. If drains don't work, stays full of water, then we go into the winter months, and now there's a potential that entire barrel is going to freeze, which one's going to damage the internal components of the hydrant. Also, if it freezes, it takes the hydrant out of service, and there's potential it may crack. Okay, so we want to make sure that the fire hydrants are draining and they're not going to be laying full of water. Moving from a dry hydrant or a wet barrel hydrant or a dry barrel hydrant, we move into dry hydrants. These hydrants are generally used for static water supply. So you'll see that this dry hydrant is installed in either a pond or a stream. It just makes our connection or our ability to draft or remove water from that static water supply much faster, much easier than if we'd have to place our hard tubes in service to be able to extract the water and pull the water from that static water source. So in the center region area, our hydrants, both State College Borough and College Township, which are our two main water suppliers, they use the NFPA system to color code the bonnet. So again, as a review, the bonnet is the top covering or that top cap on top of the hydrant. If the bonnet is painted blue, this is an indication that this hydrant will flow at least or a minimum 1,500 gallons a minute. It may also exceed the 1,500 gallons a minute. If there's a green top or a green bonnet, it's going to be between 1,000 and 1,499 gallons per minute. An orange or a yellow bonnet will be 500 to 1,000 gallons per minute. A red bonnet is less than 500 gallons a minute. In the center region, you may also find purple and gray hydrants. These hydrants are either on a non-potable water system, and they're usually on some sort of a pumped system. So there's really no guarantee of what the flow will be from these hydrants. Okay? The water inside the hydrants is perfectly fine for fireground operations. It's just that we cannot verify the actual flow of the hydrants. Those hydrants can still be used during operations, whether it's a purple hydrant or a gray hydrant. It's just that if we do tap into one of those hydrants, notification needs to be made to either Penn State, because they have a purple hydrant system, or University Area Joint Authority, I believe, has the gray hydrants. So we need to make those notifications if we're going to use that water system. Okay. So as a review, blue hydrant, 1,500 or more. Green hydrant, 1,000 to 1,500. Yellow or orange, 500 to 1,000 gallons per minute. Red is less than 500 gallons a minute. So you may find us arrive on the scene and you see a red top hydrant. You may wonder, why are we passing up that hydrant? It may be better to go down the street 2 or 3 blocks and pick up an orange or a green hydrant, or it may be a better option to use tankers or tank trucks to supply water to the scene, compared to using a questionable hydrant that only has 500 gallons per minute. So we talked briefly about the bonnet. Okay, so the bonnet's going to give an indication of what the gallons per minute flow is from the hydrant. And then we have the residential connections. Okay, and you're going to see a color coding system that works off of the same idea. So on this hydrant you see, so the top is the bonnet. The front part is what we refer to as the steamer connection. Again, as a review, these are typically 4.5 inch national standard thread. There are some areas that have a 5-inch Storts. There are also a few areas that may only have a 4-inch, and we have an adapter for that. So think the steamer connection is the large outlet on the front of it. To the left and to the right are going to be the residential outlets. So here I go with the coding system. If the residential, the side 2.5-inch ports, have a silver cap on those, that's indication that they have a national standard thread. Okay. If the residential connections are painted the same color as the bonnet, that's an indication that we have the threads are what we call an alpha bastard. The alpha bastard thread is a Pittsburgh 6, or it's a much coarser thread than what you're going to find as a national standard. All the hose in the Alpha Fire Company uses a thread pitch of a national standard. Again, if you think about the term national standard, many other fire departments in the center region also use national standard hose. With national standard hose, we can connect to each fire department, and really there's no adapters involved in it. The reason that we have a few of the older hydrants, okay, or we have them color coded the same as the bonnet, that alpha bastard is a different pitch or a different thread. So that's going to require an adapter. You screw the adapter on first, and the adapter will switch it from alpha bastard thread to national standard. And you'll hear quite a bit about this alpha bastard thread, and making sure you have that, and making sure you have that adapter as you move into your hands-on training. So with the hydrant seat also comes standard equipment that will go with the hydrant person. You'll see that the first 2 things are going to be a flashlight and a radio. The flashlight has multiple uses. The flashlight can be used for locating the fire hydrant. The flashlight can be used for identifying or evaluating the fire hydrant. And also the flashlight will be used that when you open the cap or take the cap off the hydrant, you can look inside and verify if there's any damage inside the hydrant. A radio will be used for listening to the fireground operations. The radio will also be used for contacting the driver operator of the engine, verifying that the connection has been made to the hydrant, and also verifying or listening, waiting for confirmation to open the hydrant. The hydrant firefighter will also have the hydrant bag, and in the wintertime operations, you'll use a shovel. You'll notice that the shovel is located on the rear step of most of the Alpha Fire Company apparatus. Within the hydrant bag, you'll have a hydrant wrench, spanner wrenches, which would be in the smaller wrenches in the lower left corner of the picture. Also, a larger Storch spanner wrench will be in the upper left corner. You have at least 2 gaskets, both a 4.5 and a 2.5 inch gasket. Therefore, if you lose one during your connection, you have an extra gasket to place inside the female connection. You'll see there's a ball valve in the upper right corner, the alpha bastard adapter, which is 2.5 Pittsburgh 6 to 2.5 National Standard, and a 4-inch to 4.5 inch National Standard adapter. These are all found within this picture. You'll see there's also a rope hose tool and a 2.5 to 4 inch or 2.5 to 5 inch Storch adapter. These are the tools that are located within the hydrant bag, and these are all the tools you'll go over in your hands-on operations or your hands-on training. It will explain each of those tools and how they're used on the fairground for making a hydrant connection. So the responsibilities of the hydrant person. Okay, gather your appropriate equipment. Again, what was your appropriate equipment? Your appropriate equipment would be your flashlight, your radio, and your hydrant bag. In the wintertime operations, the thing we would add to that will be taking a shovel with you so you can dig out the hydrant. As the hydrant firefighter, you'll be making the connection to the hydrant. Some will use the term here, making the hit to the hydrant or making the connection to the hydrant. You need to understand what's going on during these operations. And I'm going to review both a forward lay, a reverse lay, and a split lay. So you arrive on the scene, you see the driver or the firefighter, backstep firefighter. Before they get off the apparatus, you want to look in both directions, make sure there's no cars coming. You want to identify where the hydrant's at. You also want to look below you and make sure that there's nothing you're kind of leaving the apparatus and going to fall onto, step onto, make sure you have good footing. When you get off the apparatus, you want to be facing towards the apparatus and use 3 points of contact. So 2 hands and a foot. Whenever you get off the apparatus, please do not just jump off the apparatus. We've had numerous people throughout the years of the Alpha Fire Company injure themselves when they jump off the fire apparatus. We recently, within the last, I believe, 1 or 2 years, we had a firefighter jump out of the cab of an apparatus, and they think they messed up their knee, and it was out of service for a few months. So please take your time getting off the apparatus. Okay. So you clear traffic, and you exit the engine. Proceed to the back of the engine. On the back of the engine, you'll see, and you're going to learn about the different hoses that we carry on the apparatus. What you're looking for is the large LDH, which is a 5-inch hose, also yellow in nature. Connected to that 5-inch hose will be a large bull rope. You want to take the bull rope in one hand, or if you get off the apparatus, as you go up to the hydrant, throw your bag or place your bag close to the base of the hydrant. Head to the fire apparatus, climb up on the back step, grab that bull rope, and you're going to proceed away from the apparatus. Now when you move away from the apparatus, you don't want to hop off or step off the back of the apparatus and go directly to the fire hydrant. What that's going to do is potentially create a snag in the hose between the apparatus and the hydrant. So you want to walk away from the hydrant at least 20 feet. That's where you're going to clear. You're going to put hose between yourself and the apparatus, and then at that point, then make your way over to the apparatus, or make your way, over to the fire hydrant. Once you get to the hydrant, you'll see in the photo here, in the left photo, the hydrant firefighter has now placed that bull rope over top the hydrant. You'll see that also there's a loop of hose there, which generally gives them 20 feet of hose between the apparatus, so 10 feet to the hydrant, a 10-foot loop going back, so it gives you 20 feet of hose to work with. Okay. When you signal to the driver operator, you want to be on the driver's side of the apparatus. You want to have good visual contact with the driver, whether they're going to look out the window and look back at you, or you're going to look at them in the mirror. You're going to wave to them or signal for the driver operator to pull away. You do not want to do anything with the section of hose that's come off the apparatus or the rope that's around the hydrant until you hear the first coupler or the first 100 feet of hose drop on the ground. If for some reason you choose not to put the rope around the hydrant, you could pull the hose off and just wrap the hydrant. At least 1 or 2 wraps will be enough to secure the hose to the hydrant. As I said before, you wait for the first 100 feet of LDH to hit the ground. Once you hear that coupler hit the ground, then you can start on your operation. By all means, make sure you either remove that rope from around the hydrant, or if nothing else, you remove that loop of hose out from underneath that piece of rope. If you leave that rope or that wrap of hose around the hydrant and you charge it, it's going to be a kink and it's going to drastically affect your water supply. Alright, so here's a picture of the firefighter removing the rope from around the hydrant. The same thing would be if you had the hose wrapped around the hydrant, unwrap it. The next thing you want to do is remove the cap. So we're always going to use, if you're using 5-inch hose, you're going to start with the steamer cap, which would be the 4.5-inch cap on the front of the hydrant. You want to place your wrench on the hydrant, on that cap, and then generally, depending on if you're going to put it on the left side, understand, turn it to the right, it's going to tighten it. Turn it to the left, is going to loosen it. So you're going to connect to the front, have the wrench to the left, and you're going to push down on the wrench, and that's going to be able to loosen the cap or take the cap off. Be cautious. Some of our hydrants still have the chains on them. So you'll see in the picture here, this hydrant still has a chain that's connecting the cap to the hydrant. So that may mess you up a little bit, depending on how many times the hydrant's been painted. Could be an issue, so just work with that. Go ahead and remove the cap. You can remove both the residential and the steamer cap at the same time, or you can remove just the steamer cap. The next thing we want to do is now look inside the steamer connection and make sure that there is no obvious obstructions inside. We don't want to reach inside and use our ungloved hand to feel around. This is mainly just a visual inspection of the inside of the hydrant. Again, I referred to this before, as this is one of the reasons why we carry a flashlight as the hydrant firefighter. Once the steamer cap is off the hydrant, we want to flush the hydrant. So we're going to place your wrench on the top stem nut. Again, if you turn it to the right, it's going to tighten that stem. If you turn it to the left, it's going to open it. So you want to turn it to the left. Also, if you look on the top of the bonnet, there should be an indication with an arrow showing which way to move your wrench to open the hydrant. Whenever you open the hydrant to flush the hydrant, we only want a half a flow or a half pipe coming out of the steamer connection. Okay, I think the next picture is going to show you a full flow of a hydrant, and that's not what we're going for as far as a flushing operation. We only want a half pipe. We're only going to do this for about 30 seconds, and what we want to do is verify that there's at least flow within that hydrant. We also want to verify that we flush out any dirt and debris, so we don't want to push that dirt and debris down our supply line and then push it into the engine. Whenever you're flushing a hydrant, do not stand in front of the hydrant. Stand behind the hydrant. Also be cautious having your hands over top of the hydrant. There is a potential for the stem nut to fail, which would dislodge it in the vertical position or kind of shoot it vertical. So make sure that your head, your arms, your hands are not over top of that stem at any time. Also, as I said before, stand behind the hydrant during the flushing operations. All right, so as I talked before, the reason why I have a note on here saying this is improper flushing of the hydrant, because this is a full flow of a hydrant with the steamer cap disconnected or taken off. Again, what was the idea, or what was the The process for flushing, okay, we only want to verify that we have flow. We also want to push out any dirt and debris, but we're not looking for a full flow out of the fire hydrant. Okay, once the flushing is complete, then we're going to make a connection to the front of the hydrant. So this is your first thing you're going to need. There's going to be a 4.5 to 5 inch Storts adapter, and that Storts adapter is generally or routinely stored already connected to the end of the 5 inch LDH hose, so you don't have to go chasing that. For some reason there's damage to that connection, then you can go to the apparatus and grab one, or potentially there might be one left inside your hydrant bag. Okay, but this all the parts and pieces you're going to need for this operation should already be connected to the 5 inch hose. The other thing we're going to add to this hydrant before we charge it is we want to put the ball valve on the steamer connection. The reason for making 2 connections to the hydrant or adding the ball valve to one of the residential connections is, remember, if you're thinking if the hydrant's going to flow 1,500 gallons a minute or 1,500 gallons in excess of 1,500 gallons a minute, you may have some extra water still within that hydrant that you're not going to be able to utilize with just your 5 inch hose. There's a potential that a second engine may arrive at the scene or arrive at this hydrant. If you've already made a second connection to it or you added a ball valve to it, then the second arriving engine can hook up to that connection, open the connection or open the ball valve, and now they'll be able to use residual water left within that water system. This will also be beneficial whenever you close the hydrant, you want to drain the hydrant, or when you close the hydrant, you want to drain the pressure off the system. Having that extra ball valve on the 2.5 side is going to make your life a lot easier. So the next thing would be signaling to the driver operator. You want to verify or make sure they're ready for you to charge the hydrant. This operation can go a few different ways. So one of the ways you could do this would be a hand signal to the driver operator. Now generally the driver operator may not be paying attention or may be involved in other operations where they're not going to be able to make a hand signal to you or have a direct line of sight back to you. So generally we're going to work more towards using some sort of a radio operation. So we need to think that whenever we're doing radio operations, it's hey you, it's me. So radio communications may be something like engine 5-1 from hydrant, and then they're going to reply hydrant from engine 5-1. Then your reply would be engine 5-1. Hydrant connection is complete. Waiting for OK to charge the hydrant. Then they would reply back, hydrant from engine 5-1, charge the hydrant. Okay, so whenever you make your radio communications, you want to address first who you're talking to and then follow that with your transmission. So, hey you, it's me. So, engine 5-1 from hydrant. Okay, so think about using that from part. Okay, so once the hydrant is fully open, so most Darley hydrants are going to be 25 turns. And just think the Darley, I'm just kind of throwing it out there, it's one of the brands of hydrants. When you ever open a hydrant, no matter what brand it is, you want to open it completely. So let's say you're going to turn it 25 turns. Once you open it up, turn it back 1.5 or maybe 1 turn, or even 1/4 of a turn. Just bring it back a little bit so you take some pressure off of the stem. Once the hydrant is open, then again, radio the driver operator and verify that hydrant connection is complete and the hydrant is in the on position. Gather all your tools and make your way back to the engine or follow the line back to the engine. Please make sure you're taking all the tools with you. When you get into the downtown area, it seems at times the college students or people walking by may think that you left them a bag of souvenirs to take back to their dorm or back to their apartment. So take all those tools with you, and then when you walk back to the apparatus, follow the hose line that's in front of you, and if you see any kinks, any leaks, any damage, report that to the driver operator. There are some other hydrant issues we need to think about, whether it's a damaged hydrant, obstructed hydrant, snow and ice. So there is potential that when you wrap the hydrant and you kind of move, the hydrant's going to fall off. We've had a few cases where somebody has driven into a fire hydrant or a tractor and trailer catches it and breaks it off. Instead of reporting it, they go back, they pick it up, and they set it back on top of its resting spot. So as you drive by it every day, people think that the hydrant is connected, but it's just sitting there because it was broke off at one point. There may also be obstructions sitting in front of the vehicle or in front of the hydrant. So we know that we should not be parking vehicles in front of hydrants, though people tend to forget that. So try as best you can to work off of either side of the hydrant, or if you can get enough hose in the front of the hydrant without having a kink. If you can't get to the steamer connection, you could also use the residential connection. From the residential connection, using the 2.5 to 5 inch adapter, and you can connect the 5-inch hose to the side of the hydrant, not just in the front of the hydrant. I'm sure you've also seen a few cases where people have broken the windows in a car and they run the 5-inch in through the driver's window, across the seats, out of the passenger window, and then still make their connection. I'm not saying don't do that, but you better be able to justify why you've done that and that you've exhausted all other options before you damage somebody's vehicle to that extent. In the picture here, you'll see a hydrant that is covered in snow and ice. This is a reason why we carry the shovels on the back of the engine. One of your first operations may be to dig the hydrant out before you make your connection, before you flush, and before you continue with the rest of the connection. You'll see the first one I'm going to talk about is a forward lay. So for a forward lay, the tools and equipment for the hydrant person is going to be the same. You're still going to have your radio, your flashlight, and your hydrant bag. A forward lay is going to be the most common. As you can see in the picture on this slide, the engine is going to stop at the hydrant. You're going to make the wrap on the hydrant, and the engine is now going to proceed towards the fire. So this is a forward lay, or laying forward from the hydrant towards the fire. The next one would be a reverse lay. So for a reverse lay, the engine is going to stop at the fire and reverse lay back to the fire hydrant. Now this could be done in a few different operations. So you'll see the first engine depicted on this slide. You'll see to the right there's a firefighter making an attack on a fire. You also see this large gated Y, and then the engine to the left. So for this operation, when the engine stops, or to do a reverse lay, the engine's going to stop at the fire, and you need to think for this operation, you need to drop all your tools and equipment at the fire scene, because in a few moments the engine's going to drive away from you. So you're going to need to pull off. Generally for this operation, we could either use 5-inch hose or we could use 3-inch hose. Understanding that your 3-inch hose on the apparatus is only going to be 600 feet of a dead lay, and your 5-inch hose is going to be, I believe, 1,500 feet. So you need to think about how far away is the hydrant. When you drop your equipment at the fire scene, you're going to take everything you think you're going to need for that operation. So my suggestion is, if you're going to do this operation, take the gated Y, drop it, drop both of the high-rise packs, drop the extra hose that goes with the high-rise packs, drop the bag that goes with the high-rise pack. So this is stuff we haven't really talked about yet as far as the high-rise operations. But doing your rig checks, you understand what the high-rise pack is and the bag that goes with it. So ultimately, you're dropping as much hose and equipment you need at the fire, and then the engine is going to lay the supply line from the fire back to the hydrant. The other way you can do a reverse lay, as you see in the bottom picture, So the engine is going to pass up the hydrant, and the engine is going to go straight to the fire scene. Now the second arriving engine is going to stop at the first arriving engine. Going to connect or lay the 5-inch hose at the first arriving engine, and the second engine is then going to proceed to the fire hydrant. Whenever you're doing this operation, so if you're the hydrant person, you're going to still be responsible to stay with the engine and make the connection whenever it makes its way to the fire hydrant. So if it's a reverse lay using tools and equipment left at the scene, you want to hop off, make sure all those tools and equipment get dropped at the scene, assist the crew getting off the apparatus and getting their tools in place. But then you want to get back on the apparatus and ride with it to the fire hydrant. If you're going to do an operation where it's going to be reverse laying from the first arriving engine to the water supply, whenever you get off the apparatus, you're going to disconnect or take the 5-inch Storts to 4.5-inch adapter with you. So you went off the apparatus, pull the 5-inch hose off, situate it on at the first arriving engine, hop back on the second arriving engine, and ride with it to the hydrant. At that point, you'll still use your hydrant bag and all your connections to make the connection at the fire hydrant. So I hope that makes sense to you. It's kind of long-winded. Just understand that a forward lay starts at the hydrant, engine ends up at the fire. Out of reverse lay, the first place you arrive to is going to be the fire. You drop your equipment and the engine lays back to the hydrant. If it's a dual response, where the first engine arrives on the scene, stays at the fire scene, the second arriving lays the supply line from the first two engine back to the water supply. For the split lay, you'll see this photo shows the hydrant is located on one street and the building fire is located on the opposite street. So with a split lay, let's say that both the engines are arriving from the same direction. The first arriving engine is going to wrap a street sign or something at that intersection and is going to lay forward to the fire scene. The second arriving engine is going to stop wherever that first arriving engine dropped their hose. They're going to make a connection there, and then with their hose line, they're going to lay from that point towards the fire hydrant. So this would be a split lay. Okay, so you can either use a street sign, utility pole, mailboxes, just something there is going to situate that hose so you can lay forward from that point, and then the second arriving engine is going to pick up that hose and then lay towards the water supply. Okay. This can be used in urban areas, rural areas, maybe some industrial sites when we do something like this, garden apartments, storage areas. There is definitely a benefit to this compared to the first arriving engine. You need to making a complete hose lay from the hydrant around the corner to the fire, knowing you have a second arriving coming. Plus, the benefit of this is it puts a pumping apparatus at the fire hydrant. For some reason, there's low pressure at that hydrant. You're not relying on the pressure from the hydrant to push the water through the hose line to the first arriving engine. For this operation, you'll have actually have an engine sitting at the water supply. All right, so something a little extra I talked about here. Remember, I talked briefly about something obstructing the fire hydrant. So you can see on this one, making a connection, around the car, may have made too tight of a kink in the hose. So they chose to take the windows out and run their hose line through the windows, through the driver's side rear and the passenger side rear to make the connection. Please, I'm not going to tell you you can't do this, but you better be able to justify why you've done it. Is the brake position or the brake firefighter? So the brake position, the brake firefighter is responsible for making the connection from the hose bed into the engine. After you make the connection from the hose bed or supply hose into the apparatus, then you can be reassigned to other operations. These other operations may involve the second attack hose, the backup line. You may be throwing ladders. You may be assisting with interior operations. Whenever you make the break, make sure you speak with the driver operator if they have no other needs and all their needs are met, then you can go on and be reassigned. From that point, I'd not to suggest you be reassigned from the driver operator, make your way to command or manpower, and have them reassign you with a different crew or give you an assignment to take care of. The equipment for the brake firefighter. You're going to need a flashlight, a radio, the supply line, spanner wrenches, and short sections of supply hose. For daylight operations, you may not need the flashlight, though I still recommend you have a flashlight on you at all times. Again, the radio may not be a necessary piece of equipment for the brake firefighter because you're doing face-to-face verbal communications with the driver operator. But again, we recommend all firefighters on the scene have a radio with them. So still, flashlight, radio, take them with you. The supply line is a part of your equipment because you're making the connection, or you're going to disconnect it from the hose bed and make connection into the apparatus. The spanner wrenches are going to assist you with making those connections. And as I said before, there are going to be a few short sections of hose you'll locate on the apparatus that can be used if you do not need another 100-foot section of hose. So once the apparatus comes to a complete stop and you hear the air brake come on, then you're going to exit the apparatus. Again, this is going to be the same as when you're riding the hydrant seat. You want to use 3 points of contact getting off the apparatus. You want to clear the area below you, and you want to make sure that there is no approaching traffic in either direction. You're going to make your way to the back of the apparatus, where you're going to disconnect the hose from the hose bed. And you want to make a connection into the passenger side of the apparatus, or the large steamer connection. You'll see in this picture, the lower right corner, we carry 2 different lengths of hose on the apparatus, of 5-inch hose. We carry 100-foot sections, which will be in the hose bed, and we carry 2 25-foot sections of 5-inch in a belly pan on the passenger side of the apparatus. If you make the break, or you make your connection and you are within 30 feet of the apparatus, okay, with that last coupler, then you can put the 2 25-foot sections together to finish up your final 50-foot to get you from that connection into the side of the apparatus. If you are more than 30 feet away from the apparatus, then pull the extra 70 feet off the hose bed and make a large loop before you make your connection. And these are operations you'll go over in your hands-on training. So just understand that if you're within 30 feet of the apparatus, you don't need, or within 20 feet of the apparatus, 30 feet, maybe you're right there at a 10-foot mark, you don't need to pull an extra 100 feet of hose off the apparatus, and there's extra 100 feet of hose you need to deal with, when you could easily have grabbed a 25-foot section or put 2 25s together as a 50-foot section to make up that difference. Okay, and that's really just a judgment call on the brake firefighter to make the connection into the apparatus. And here I'm just talking about, a picture to show as what I've already spoke with. You'll see the position of the brake firefighter in relation to the back of the apparatus. So I would say they were only, maybe 10 feet, 5 to 10 feet off the back of the apparatus. So for this, I don't want to pull another 100 feet of hose off and really need to get rid of most of that to make my connection into the side of the apparatus. You'll see they're making a connection here with either 1 25-foot section or 2 25-foot sections, and that's just going to make up the difference between wherever the LDH lands coming off the hose bed and what little they need to make up the rest of it from that point into the side of the apparatus. Again, this is going to be a judgment call for the brake firefighter. Now, whenever you make your connection into the apparatus, you're using the officer side intake. Okay, so I also refer to the officer side or the passenger side of the apparatus. And that should be the large 5-inch intake close to your waist. You'll see in front of this firefighter to their upper right side, there's also another 5-inch storage connection, which looks just the same as the intake. Understand that for the engines in the Alpha Fire Company, at least engine 5.1, 5.2, and 5.3. It's a little bit different for engine 5.4, but engines 5.1, 2, and 3. Any connections really above the waistline, up close to your chest, are going to be discharges. Anything at your waist or below are going to be intakes. So you want to make sure that you're connecting to the intake. Once you make the connection, you want to go to the driver operator, have a face-to-face, not really discussion or anything, but you want to let them know that the connection is made, and then have them reassign you, or as I said before, then make your way to command and get a reassignment. But your job as the brake firefighter is make the connection from the hose bed into the apparatus. Now, for most operations, depending on how heavy the crew is for the day, if we're running with all 6 people, then the brake position is a needed position. Is going to be one of the positions that's filled. If we drop to a 5-person crew, the brake position is the one that goes away. The brake position is going to be filled from the driver operator, or possibly the backup firefighter may do the brake position. Okay, so if you're running with a 6-person crew, all 6 seats are filled. If you're running with a 5-person crew, the brake seat's going to be empty. If you're running with a 4-person crew, you're still going to keep the hydrant position is always going to be a required position, which that person may be moved around a little bit, maybe a backup firefighter. But always remember that hydrant is a priority, nozzle person is a priority seat, driver operator is a priority seat, and the officer is a priority seat. All right, so moving on to rural water movement operations. So depending on which part of the country you're in, whether we're talking about tankers or tenders. So the joke is in the West, that the western part of the country, that tankers fly and tenders drive. Okay, so for the east side, we've always called them tankers, so that's what we go with. In the picture here, this was the old tanker 5.2. It was recently replaced, spring of 2022. So we no longer have this tanker, but this was the predecessor of what you see sitting at the Patton station. All right, so for rural fireground operations, 4 key points to this are going to be drafting operations, the tanker shuttles, working with a dump site, and then again also working with a fill site. So the process of drafting is a process of raising water from a static source to supply a pumper, known as the drafting apparatus, or known as drafting. Okay. So in theory, this is something you're going to learn when you go into your mod classes, or if you're going to become a driver operator. Truly, we're not sucking the water out of the pond or out of the stream. We're just lowering the pressure within that suction tube, and atmospheric pressure ultimately pushes the water up into the apparatus. Drafting operation is going to occur whenever we do not have a pressurized water source or a hydrant to work from. Okay, so this may be a rural fireground operation where we're using tank trucks to supply the water to us. We're going to dump it into a tank, and then we're going to supply it into, or draft it into, the supply engine. So for drafting operations, there are a few different parts and pieces you're going to need. You're going to need hard bars or suction hose. Okay, so this is generally like a 6-inch suction hose, a flexible hard pipe. A strainer. Strainers can either be a barrel strainer, which would be the one in the middle, right, or the right side of the slide in the middle. A low profile strainer used for water out of the dump tank. And then we also have a turbo draft, which will be to the left side. Engines 5, 1, 2, 3, and 4 all carry drafting equipment, which would be the hard bars, strainers. The tankers carry the low profile strainers. Quint 5 is the only kind of oddball of the mix. Quint 5 does not carry strainers or hard bar. It carries what you see here as a turbo draft. And the turbo draft is an operation where you use a 2.5 or 3-inch hose inlet. It creates a venturi and pushes water, per se, from the supply source back and pressurizes the intake side of the quint. So this is one of those operations that if you don't go over it during your water supply practical training, this is something you'll see on one of the company level trainings throughout the year. All right, so here's a drafting operation. So as I said before, you have the engine sitting there, you have the hard bar that goes into the water, and connected to that hard bar is a strainer. Whenever you make this connection, you also want to tie a rope to the end of the strainer. The idea of tying the rope helps you position the strainer, whether you position it up off the bottom of the stream or the bottom of the pond. If you're working with a pond that maybe has too much silt, you could lay an extension ladder from the edge of the pond into the pond itself and lay your hard bars on top of that, which would be a way of suspending the strainer up off the bottom. But truly make sure that you're tying a piece of utility rope to the end of the strainer. All right, so for this operation, the hard bar is placed in the water, and as I said before, what we're going to do is we're going to lower, using the pump of the apparatus, we're going to lower the pressure, the atmospheric pressure inside that tube. So we have a higher atmospheric pressure outside the tube, a lower pressure inside the tube. Atmospheric pressure is going to push the water up into the pump. All right, once we have the water into the pump, then we can create pressure within the pump and send it down the line. For tanker shuttle operations, we're going to need 3 main components, which will be a dump site, a fill site, and then tankers or tenders to transport the water between the two. The dump site, is going to be generally located near the fire. So think of the dump site as a man-made water supply location. The dump site is going to consist of a supply engine and at least one or more, so at least 1, 2, I say 2 at minimum, portable water tanks. And the supply tankers or tenders are going to dump their water into the portable tanks. Once they're empty, they're going to make their way back to the fill site. The apparatus attacking the fire or the supply engine from the dump site is going to pull the draft and then supply the attack engine. So at the dump site, tools and equipment you're going to need will be the hard bar. So you're going to set up another drafting operation. You're going to use the low level or a barrel strainer. Try to use the low level strainer if at all possible. And then you'll use a dump tank. Each of the tankers in the Alpha Fire Company carry a portable tank, and they are also sized to the water tank on the apparatus. You can dump the entire tank of water into that dump tank and then go for another load. Okay, so here's a picture of the dump site operations. You'll see that the portable tank is placed on a tarp. So the reason that we're going to lay a tarp down first is just give us an extra layer of abrasion protection. So the tarp goes down, the tank goes on top of it, and then the supply tanker is going to fill the tank and then go for another load. The supply engine is going to set up a drafting operations from that water tank, and then they're going to supply the attack engine. Now, depending on what operations or where we're operating at, this dump tank can be placed beside the attack engine, or it can be placed beside a supply engine, which is going to take care of the water supply operations, and then it's going to supply water to the attack engine, which sometimes is a cleaner operation. That way you're not relying on one engine or one driver operator to do all the functions of both fire ground, fire attack, and water supply operations. So here's a picture of a general setup with the dump tanks beside the water supply engine. On the top picture, the 2 water tanks can be attached or positioned side by side. And you'll see there's a hard bar between the 2, which is going to be transferring water from one tank into the other. These can also be placed at a diamond pattern. The idea of placing a diamond pattern spreads the tanks out just a little bit, so you can potentially have two tanker or two tenders filling both tanks at the same time. When you put two tanks side by side, sometimes it gets a little bit too tight to have two tankers sitting there at the same time. The position of the dump tanks may change also. So if it's rural operations where you have one, like a 2-lane road with limited accessibility, the dump tanks may be moved to the front of the apparatus using a front intake, which at that point only takes one lane of travel out of service. So you still have a lane of travel for the tankers to both arrive at and leave from the scene. So here's what I'm thinking as far as I originally talked about the attack engine not taking on both water supply and attacker itself. So this is an operation where you're going to learn using a first arriving tanker or tender and then a later arriving engine. And they're both going to work to supply the attack engine. So in this picture, the engine arrives first, positions themselves, they're going to be the attack engine. They may lay out, so in theory, they're going to lay out from the driveway and lay 5-inch hose. So the first arriving tanker arrives on the scene, and located in each of our tankers is a large 5-inch Siamese. So a Siamese takes two 5-inch connections into one. Okay, so a Y splits a line into two smaller lines. A Siamese takes two larger lines into one. So this first arriving tanker is going to attach their Siamese to the supply line, and from their tank truck or their pump to the Siamese, and then they're going to start pumping water. So they are supplying the supply line with the tank water, okay, or with the first arriving tanker. When the engine arrives on the scene, so the second arriving engine is going to set up a drafting operations. So they're going to place a draft tank or a water tank behind the tanker, and they're going to start a drafting operation. They will connect into the other side of the Siamese. So now we have a continuous water supply from the second arriving engine connected into the Siamese, supplying water to the attack engine. Once this setup is complete, the first arriving tanker can disconnect, and then they can go about their operations as a water supply unit or as a tank truck hauling water. The way the Siamese is set up is there's a flapper valve inside that Siamese. So as long as it's getting a pressurized source from one of the two, whether it's going to be the tanker or the second arriving engine, that hose line is always going to remain charged. And again, this kind of sounds like a lot on words, but during your fireground operations or your water supply operations, hands-on training, they'll explain the use of the Siamese valve for this operation. All right, so fill site operations. All right, so this is the operation where we're going to set up a fill site using a static water supply or a static source. You can also use a hydrant for a fill site. So most apparatus in the Alpha Fire Company are carrying 1,500 feet of hose. So you think about it, if you're going to be have an operation where you're 1,500 or more feet between the supply source and the fire itself, it may be more beneficial to just haul the water between the two rather than pumping it. Okay, so we get into the rural areas of Patton Township, Ferguson Township, College Township, or we go mutual aid in Huntington County or mutual aid in other parts of Center County. A water hauling operation may be the best way to do it. So at this point, we need to set up some sort of a fill site. So tools and equipment used for a fill site. You're going to have 5-inch supply hose, a manifold, 2 to 4 sections of 3-inch supply line, If we're drafting from a static water supply or water source, we're going to need the hard bars and strainers. If we're working off a fire hydrant, we may only need a short section or a short sleeve of 6-inch hose or a short section of the 5-inch hose to make a connection from the hydrant into the water supply or fill site fire engine. So you'll see that we have this manifold. So we're going to set up the same operation as what you would see for the water supply engine when you set up a draft site, or you make a connection from a hydrant into the engine. This will be on the back side. Okay, so we're going to take a 5-inch hose off from a discharge. From that discharge through the 5-inch hose into the manifold, and you'll see this manifold takes one 5-inch line and breaks it down into 4 3-inch lines, or has 4 2.5-inch connections. When going back to the equipment that I briefly talked about as far as a fill site operations, you're going to start with at least 2 100-foot sections of 3-inch supply line. Each of those 200-foot sections of 3-inch supply line are connected to the manifold, and on the end of each of those 3-inch supply lines, there's going to be a Storts connection. That Storts fitting is a standard throughout Center County for all tankers or tenders, and that's what you'll use for your connection into the apparatus. All right, so in the understanding, from your supply engine through a piece of 5-inch hose into the Siamese, and then two hoses from the Siamese into the fill apparatus. Just fill one at a time, have one connected and being filled, and then have the other one connected and waiting to be filled. And once the first one's filled, close the valves and then open the valves and start filling the second one. Alright, so for fill site operations, the hydrant seat or the brake seat will assist the driver operator with setting up all the hose lines for this operation. It's not uncommon for a fill site operation, the entire either 4 the 6-person crew stays together, and your engine is assigned the fill site operation, so everybody works together to meet those objectives. So here's another picture of the operation I was just briefly talking about. So you'll see the upper right hand picture. The 3-inch hose is connected with Storts fittings onto the back of this water tanker, and the bottom picture is the 5-inch hose supplying the manifold. And again, the manifold just takes that 5-inch hose and breaks it down into 4 smaller manageable hose lines, and each of those have a valve. So this is where we talked about 2 lines going into one tanker, maybe 2 going into the additional. When the first one's filled, close the valves and then open the valves for the second one, start filling that one while you disconnect the first one, replace it with another tanker, and then again just keep continuously completing the operation of filling, disconnecting, reconnecting, and filling the next. So once initial operations are complete, process of filling tankers will be very systematic. So you'll line them up. So generally this works best if you find a large parking area, or you lay out your hose lines. It makes it more accessible for the apparatus arriving on the scene. You want to do the least amount of backing of apparatus as possible. So you set yourself up, the apparatus arrive on the scene, position themselves, make connections, fill them, and get them on their way as efficiently as possible. The schedule is located in the description of the video on the YouTube channel. So go ahead and take a moment, go back to the channel, look in the description area, click on the SurveyMonkey link, and then complete the quiz. Again, I want to thank you for your time and reviewing water supply operations. Use this as a basis of what you'll be doing on your hands-on operations within the Engine Pert program.